quick reminder here about computer architecture and specifically storage structure, so things that you've already seen from the computer architecture course. So we know that the storage devices are actually organized in hierarchy by different criterions, things like speed, cost, volatility. So we've already seen this in computer architecture. So we have the devices range from things like magnetic tapes all the way here in the bottom, which are big in capacity, right, but very slow in terms of the access time. Now on the top here you can see things like main memory. This is your RAM, right? And we have the caches and the CPU registers. So these are very, very fast compared to the devices in the bottom, but the problem is they're very small in storage capacity. So more about computer system architecture. This is to remind you about the things that you may have already known from other courses. So these are the main terms that we use in computer systems, right? The CPU, which is the main hardware where all the different system instructions are executed. And we have the processor, which is the physical chip where the CPU exists. And then the CPU itself has a core, which is really the main basic unit of instruction execution on the CPU. And you can have one CPU with multiple cores. That's what we call a multi-core CPU. Or you can have a system that has multiple processors, and that's what we call a multiprocessor system. So this figure shows the difference between having a multi-core system right here, a multi-core processor, versus multiple processors. So here the main idea is you have one chip, right, and different cores on it, versus having 4 chips right here. So obviously this is cheaper, and the communication is very much faster, and it's really energy efficient. So this figure right here again remind you with the concept of the communication with main memory, and the processor always needs access to main memory to retrieve data and instructions, and it's really the only type of memory that the processor can access directly. So the processor cannot really access the hard drive directly, so it goes through the RAM or main memory. So this is a multiprocessor system, and you can see here that every processor has its own registers and cache for local fast retrieval, and then they connect through the bus again, as we said, to the main memory. And here the concept of symmetric multiprocessing. Most of the processors actually treat all processors the same, so it's symmetric. All the processors can actually do all types of processing, versus there's other types of architectures where you can have a dedicated processor for specific tasks, and so on. So it's not symmetric in that case, but the most main type of systems are symmetric. This one shows, on the other hand, the concept of multi-core system, and here specifically it's a dual core. So you have one processor with 2 cores, right? And every core has its own, again, register and cache, and both of them can communicate to another level of cache. And then at the end, of course, the processor has to access main memory to retrieve data.